Okej. Słyszałem, że możemy zaczynać. Oh, sorry, this was supposed to be in English. So I've heard that we can start. And hi, I'm Michał Gryko, and today I would like to talk with you about the different approach to scripting. So different programming language used as a scripting language, and the way that we don't always need to use Bash to produce scripts, to manage scripts that we work. At the beginning, I would like to make a quick poll. So how many of you work as operations people? So sysadmin, DevOps, SRE? Okay, few of them. How many people as developers, pure developers? Okay, so mostly developers. I hope that you'll find few interesting things here. I'm working as a site reliability engineer in Nordea Bank, so this is my day work. You can find out more on our Nordea page or on my very empty blog. Yes, so today on the show, what I'll be talking about. First, I will try to explain what's actually wrong with Bash, why I'm trying to talk about that. Second, I will make a short introduction to Go, because the language that I would like to tell you about is Go. And then I will show you how to script in Go, and then we'll have some time for questions if you will have some. So what's wrong with Bash? You may think that what this guy is talking about. My grandfather used Bash, my father used Bash, I use Bash, and probably my son will use Bash, and this is how the world works. So this is how, oh, okay. Woo. I think they will. This is my grandfather that used Bash, or one of your grandfathers, and he's totally trying to protect that technology. What's wrong with Bash, actually? What I'm talking about? So in general, nothing is wrong with Bash. If you know how to use it, if you know how for what to use it for some small things, then it's okay. It's totally okay. You agree with me? Yeah, he agrees. So it's totally okay to use Bash for some small things, small proof of concept stuff, very testing IDs or something like that. It's perfectly okay to do so. So what are the problems? Well, sometimes you land in a very dark and smelly place without any light, and you even start to decorate it a bit to make it a more cozy, and everything seems to be fine. It starts to be okay. Then your friend comes in and say, hey mate, doesn't bother you that it's so smelly here and so dark? And at that moment, you just start noticing the things that you before didn't notice or didn't want to notice. And it's the same with Bash. So I'm sorry that you heard that from me, and you probably will start noticing new things about the Bash if you didn't start to notice them already. Let's see some examples. The obvious one, the bigger script in Bash are totally unreadable. So everything above 100 lines is very hard to read. It's usually a lot easier to... Nordea! 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 Nope. Okay. So anything that it's bigger than 100 lines is totally unreadable, and you probably will have easier time to just rewrite it instead of trying to understand what it actually does. Second thing is that there is nothing that is built in that allows you to manipulate data. If you actually want to manipulate data, you will need to use JQ, sed, awk, and if you use awk, why write in Bash? You can write that script in awk. It will be simpler and less calls in the system. Grep minus E for some regular expressions, all that stuff. Those are not built-ins. Those are the tools that needs to be installed in the system. So you need to manage and declare your dependencies. how do you declare dependency in Bash? In Python, you have I don't know, requirements.txt. In Java, you have pom.xml. In Node.js, you have package.json. In Bash, you have nothing. There is no way to define dependency in Bash. So when you move your script from server to server, from system to system, you may be surprised by the fact that something is not there. There is no 7z, or it's in different version. You need to have a way to version and define your dependencies. And Bash lacks that. You moved from Red Hat to Ubuntu, or from Ubuntu to Red Hat, then too old version of 7-zip, or 7-zip is called P7-zip instead of 7z. It's your problem now. So you need to be prepared for a lot of stuff. So if you want to create a robust script, then it will be above 100 lines only to provide the robustness that you can have. Syntax is very not intuitive. So for example, how you declare array. It's declare minus small caps A or capital A. Capital A declares associative array, and the small caps A declares numbered array. So both will work, but will declare totally different array. And it actually changes between Bash versions. So if you are sure that you have Bash 4 point something and above, then declare minus A will work as you expect. If you have lower version, you might be surprised. And Red Hat has lower version to surprise you more. Yeah, how to print array size. You need to put a hash tag before array name. So wait, hash in Bash is a comment, yes? No, but not at that time. At that time, it's printing array, so size of the array. Why? So how you want to print a keys from array? You need to put an exclamation mark there. Exclamation wasn't negation? Yeah, usually yes, but not that time. That time, it behaves differently. So that's are the things that the Boolean checks, the minus GT or all that stuff. This is the usual stuff that have problems for many people. You just cannot use normal syntax like in any other language. There are 4 or even 6 ways to increment a variable, if you like to do that. A lot of. How you declare parsing the flags that you pass to the script and the parameters to the functions. How you declare in Bash what parameters functions take. You don't, but they take parameters. They take parameters, and you need to somehow define for others how to use your functions, because some people create so complicated things in Bash that they have including library files that will help others to build some kind of scripts. So there's scripts that include scripts usually in bigger projects. And if you import that library Bash, then you need to know how to use it. So there is a lot of documentation. If this documentation is correct, do you believe the person that written it, that it's still maintained and it's correct? There are some good practices that you always rewrite every variable, so from $1, $2 to do proper names at the beginning of each function you defined. But then it's bigger. Someone will just put $5 and won't rewrite the variable, and whole idea is wrong. So you need to be very careful on the code review part, and it's very, very problematic. Same with the parameters for the script itself. How many parameters script will accept? How many do you need to put? What are the defaults? You need to write hundreds of lines to just parse what people put, and then try to convince them or tell them what needs to be there. A lot of work that needs to be done. Yeah, I think that Bash is a great job protection system. If you create complicated enough script, then you're totally sure that no one will touch it and you will have your job forever. So until someone will try to rewrite it. So let's move to the things that can replace. So what can we use? As I said, we can use Go. why we can use Go. So what's Go actually? Who heard about Golang? Yeah, almost everyone. So this language was open source in November 2009, so it's like 10 years old almost. And it was born from the need of simplicity inside of the Google itself. So at the beginning, it was used mostly internally at Google. Now it's more wide open. And authors of them, Robert Graysmer, Rob Pike, Ken Thompson. Robert Graysmer worked on V8. V8 is the JavaScript engine that most of the browsers currently use, except of the Firefox. And Java Hotspot VM is the actual JVM that you're currently using. So at some point, the company created separate VM that they called Java Hotspot VM, but Sun both them, and this is actual JVM now. So Rob Pike worked on Unix, Plan 9, UTF. Ken Thompson is co-creator of C language. So why I'm talking about that? Why I'm saying that those are the authors? Because those are not random guys that decided to create a language. They people create languages and operating systems for decades. They perfectly know what they are doing. So that's why I would like to emphasize that this is not some random language created by some random students, but language created with very thoughtful design and by the people who actually know how to build a language, how to build an interpreter for it to be very efficient. Yeah, so does actually anyone uses it currently? Yeah, for example, them. So Docker, Kubernetes, etcd, Consul, Terraform, Vault, Grafana, Prometheus, Hugo, Packer, and many more. Anyone uses any of those tools? Yeah. So if you want to interact with them, do you think in which language would be the best client library created? So if you want to write your own, let's say, interface or some tool that would interact with those, this will be in Go, because all of those clients libraries are written in Go by default and then translated to different languages. So most up-to-date, most feature-complete implementations will be in Go. Why Go? Why someone would choose Go instead of Python or instead of Java? Well, the selling points for Go is that it's statically typed, but many languages are statically typed, so that's not a problem. Can be compiled to static binary. So if I will show you the use case when we are using that as a script, but if at some point you decide that you don't want to install Go interpreter on some server, then you can just compile it to the binary, copy that binary to the server, and this is statically linked binary. There are no other dependencies, other jars to copy. You copy only that file, the executable, and it will work exactly the same way as on your laptop. So that's a feature of the static compilation. This is the default mode. By default, people compile the Go programs to executables. I will just show a different approach with scripting. The syntax is really simple. There is a really simple syntax. Nothing will surprise you. If you now open GitHub and look up for any Go related project, you will be probably read it with ease, and you will understand what that project does. So a lot of focus was put not to make a language complicated, but to make a language easier to read. Why? Because developers mostly read code. The amount of code that is actually written is probably like 10 or 15% of your work time. Mostly you try to read the already written code and try to grasp what to change, what to alter, how it works, how the person that written it before me what he was or she was thinking about. So try to understand what's created, and that's why there is a lot of focus on the code readability. There is a huge standard library that you get with the language. So web servers, CQL basic driver, JSON parsing, compressing, uncompressing, all that stuff is already in the Golang. You don't need to import external packages for it to do. So that's why creating a simple web server is like few lines of code and done. Simple concurrency and multithreading. If you have application that needs to work on vast amounts of data, then it's very simple. I'll show you on the code example. There is a built-in doc generator, so you just type go doc, and it will generate documentation for all the functions in the packages that you created that are publicly exported. So very easy to create the documentation for others. It will split out an HTML file that you can just put everywhere, and that's it. It's multi-platform, so you can build for Linux, Windows, MacOS, BSD, Solaris, and it's built into the tool chain. So if you're on the Linux and you want to build a Windows executable and copy it to Windows and execute, you'll just type go/os equals Windows, go build, and it will build your application. That's it. You don't need to download anything, set up some toolchain magic. No, you just type the name of the OS that you want to have executable. Architectures, x86, so 32, 64 bits, ARM, and WebAssembly. So yeah, you can compile natively, go to the WebAssembly and run it in the browser, as you would on your laptop. It's not fully optimized, so it's not that fast, but it works. So yeah, can we just do change mode plus X on all our Go files and make them executables? Straight out of the installation, no. But I will show you a trick how to do that. So in simplest, you just type go run script go. On that side, you see an example script in Go, very simple one, but we won't cover that right now. So we want to execute that, and we just type go run script.go. Problem with that is that every time we want to run it, we need to type go run, go run, go run. This is not convenient. We can do better. And second problem is that exit code will be incorrect. So I'm especially failing here with exit code 30 because I would like to pass it further, for example. And if I check the exit status, it will print 1, and Go will add exit status equals 30 as a last line. So this is not something we would like. Second approach is to install simple binary. Here you see how to install programs written in Go. You just type go get and rep of the program. It will download the source code, compile it, and put it into your user local bin if you like. So it's like straightly available to use. Then you can start to type go run script go. Basically the same is in typing because only space is missing. Problem, we need to type go run, go run, go run, but the exit code is correct and there is no additional line like with the wrong exit code. So yeah, this is something that actually start to work. And one thing that it's missing is just the change mode plus X, so we can just run it as a usual bash script. So we can use binfmt. binfmt is a mechanism in a Linux kernel that you can define any type of binary or any type of file with extension and add an interpreter for it. So it's built into the kernel. You don't need to install anything. It will be there. It has full systemd support, so if you have already systemd, it's very easy to use. And most of the system currently have systemd, so it shouldn't be a problem. And we bypass the issue with shebang because in Go, hash is not a command sign. So if you start with shebang, some Go run interpreter, then it would fail to compile because in Go, a hash isn't a command. So how to do that? Quickly, I will just describe that line on the next slide. So you need to put a magic line into the special proc file, and then you can just do change mode, just run the script, and it will run as before. Very easy, very convenient. So how it actually works with the binfmt. Format for the line is that you put the name, type, offset, magic, mask, interpreters, and flags. For the type is the thing that if we are using magic, so magic is the first bytes of the file, or if we are using the file extensions, so .go, .php, .anything. Here we are just using the Go extension. So everything that it's after last dot will be compared to that. If it's Go, then the interpreter will be run. The name itself is just a name. We can put anywhere anything there. There is no check for that. This E is actual type, so we are using extension. Magic. Magic is not magic is in type of extension is just the extension, so it's Go. There is no offset. Offset is only for the actual magic, so we can just set the bytes and we just can offset. So don't take the first byte, but they take the third and to the fifth byte of the file to check what's the magic. We don't need to start with the beginning. And mask, we can mask some bytes of the magic. So for example, if you want to create an interpreter for JPEG files, JPEG have many types and versions, you can mask the version and use the same interpreter for every JPEG, and you can make JPEGs executables. Why not? Because you like. Interpreter is the actual program that we will run, and flags in our case are OC. O is that the interpreter will receive already open file descriptor from the kernel. So that's even if the interpreter cannot read the file because it's run as different permissions or something, it will get it straight away. And the second benefit is that it already gets the file descriptor. So there is one call less to the kernel to actually open. So the binary don't need to have a round robin to kernel to actually open the file. And C means credentials. So writes are calculated based on the actual file that we are running, not by the interpreter. If this would not be put there, then the user that runs the script will be the user that owns the interpreter. So probably root, or it's not something that we would like to have. So we put credentials here. Very simple. You just put one line with very clear description. It's in the kernel manual. Problem is that by default, BMFMT registry is in proc. And by design, proc is not persistent. It's memory file system, so it will be empty after every boot. It needs to be mounted again inside of the proc because it's like subsystem in the proc, and repopulated with that line. Yeah, one line or one script at the beginning. But systemd and FMT for the rescue. So there is already systemd service that do that for you. And on my laptop, it was by default enabled. So there was no problem with enabling that. So you don't need to mount. Everything that you need to do is to put your magic line that we described before into the etc bmfmt.d and then some conf file. I've just used name Golang, but it's totally an arbitrary name. And you can use anything here. And that's it. After that, on every reboot, it will just work. You will just fire and forget. So if you want to make PHP files executable, then why not? You just add it. If you want to make JPEG files executables, you can just add it. You can do it with anything based on either file extension or the beginning of the file to trigger it. Yeah, full success. So simple, so DevOps, very, very clear, so systemd, very nice. Now, as we know why I would choose Go and how to make Go run as a scripting language, let's see some actual scripts in Go that will present what I'm talking about. So parsing parameters. How to parse parameters by default without checking it. This is a very simple program. Do you see it at the end? OK, so we just import internal packages flag that will parse the flags. FMT will just print stuff to the screen. So I'm defining my flag, naming it param, and I'm giving it default value and the description. And I'm just parsing it, and that's it. I can use it in my program. So that's the whole thing. Let's see maybe how it works. Let's try to. I have it combined here. So this will be params. As you notice, I'm just... Yeah, so now I've run it without anything. So param, very same default value, because that was set in the code. And I can do -help. I didn't define -help in the code. It's built in by default. So all the flags that I defined will be listed here. And my flag is param. And the code, actual code that I've run, you see here. So you see that there is very same default value, some useful stuff. So you can set a default, you can set it required or whatever you like. And still you have access to all the parameters that you pass after that. So let's try to, let's try to do that. So now I've replaced my default parameter with foo, and I've added additional parameter bar that doesn't have the flag defined, so it will be just listed as the additional arguments. Very simple to use. It's defined what's there. You know that it's a string, so it will be parsed as a string. If you put a number there, even with some e plus something, it will be interpreted as a string. It won't try to do some magic stuff and convert it to the number. It will be a string because it was defined as a string. So very useful and very easy to use. Let's move to the second script maybe. I will just present from here so it will be easier. Script that reads standard input, because usually when we work with the bash, we just do something, something, pipe, something, something, pipe, something, something. So we build a snake and then execute it. And you can do the exact same thing with Go. How to parse? We just defined the new buffered scanner. Buffered scanner won't consume any memory and will control the speed of the digestion of the data. We just say that we want to scan line by line, and if there is some error, because scanner here has a standard input, but in general it accepts any stream as a method. So it can be some kind of network stream, and that stream didn't end it, but there was some error. So here you can catch this error, let's say, and process it. So script will react. Something that in bash it's almost not doable. Let's try to see how it works in reality. Yeah, let's put that one. So I've just put 2 lines. -e means process the \n to my stdin.go, and we have welcome line. So everything works as it should. See that it was compiled quite fast. So it's a very simple program, but in general there is no time to compile it. It's sub-second compilation time, so it's very, very simple. Docker client, something interesting. So as I said at the beginning, the client libraries for all the stuff are also written in Go. So we can use native Docker client library, the same that actual Docker command uses. Very same client library. This is a table writer, so it will just print it pretty way. So you will see that it's more prettier. And that's it. Those are the defines that I'm importing. I can put a version here if I'd like. I would always like to use the newest one, so every compilation will use the newest one. But in general, you can put a hash or a tag version here, and it will be actually versioned. So very easy to check what's needed. What is below? So this is the whole script, and the script, what it does, it lists the images. So it's very similar to Docker images command, but it's just an example. You can run anything that Docker command can with this because you have the same client library. I'm just presenting it in a simple way. So I'm creating a new client that will use environment variables. So if you already have Docker environment set by your environment, where is the Docker host, where are the TLS keys, all that stuff, it will just read it same way as the Docker command because it's the same client library. Then I will just CLI, so ask the CLI image list context in who knows what context is the usual way that we put it for every request in Go. Context here is the background, so it actually doesn't define anything, but you can define a context that have, for example, timeout. And it has a built-in timeout by default because you're saying that your client, for example, doesn't want to wait more than 10 seconds. Whatever the Docker daemon will be doing, or any other service, because context is in every package right now. I don't care if it will take more than 10 seconds. So the backend should stop processing after 10 seconds, because the client won't wait for it anyway. So this means that it will be cancelled in the processing loop. So we won't waste resources to produce output that no one really wants or waits for anymore. Very useful for web backends. Yeah, I'm just putting the default options because I want to have all images, but here you could do some filtering or stuff like that. I'm creating new table with name, size, and created, and I'm just putting the output there in a loop. So you can see that it's very convenient. You just range for images, and you just get in that things the key and value for each image. The key I'm not concerned about because it will be just 0, 1, 2, 3, so nothing. I'll just put underscore here, and the image is the actual content of the image. And this is a data structure. So data structure, and I have fields that image repo tag, image size, and image created. Let's see how that works in reality. I hope that you will see anything. Docker client. Now let's try to maybe make it a bit smaller, so it will be more readable. Yeah, now it's maybe not readable as text, but it doesn't matter because we see that there is like a image name, size, and create date, and we have a nice table. So this is very simple example that we just list images, but you can expect that you can do almost anything. So if you ever created a script that you needed to parse output from Docker command, or try to think about what format to put in the formatting, then why bother? Why to try to grab or ask or JQ of output of the Docker command if you can just write a very simple script that will do it for you, and it's very clear and easy to read. So yeah, that was the main use of that example. I've also said that there is very easy to do the concurrency and multi-threading. So this example is very simple. What it does, I've defined function say that accepts a string. What it does, it iterates 5 times by sleep 100 milliseconds and just print what it gets. So if I run it now, it will say world and say hello. So we will have world, hello, 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 hello. Normally, no multi-threading. We just run one function, and after that, another function. Let's see how that actually started to work. And where is your terminal? Your terminal is here. I will just increase it. And yeah, I added time here. So we see that it worked as expected, and it took 1 second because we waited 10 iterations, 100 milliseconds each. I've lost the time. So, okay, I hope that I'm not over time because I've lost it. It doesn't display time. Okay, yeah, so now let's modify it. Okay, I am just finishing. Let's modify it to be concurrent. How to make it concurrent in Go? Yeah, we just type Go. And that's it. Go say world. Let's try to see how it will behave now. I'm doing the exact same thing. Hello world, world, hello, hello world. Yeah, it was just scheduled, and it took 0.7 seconds because it needs to recompile it. Let's run it another time. It was cached, so now it took half second. So something that you would be expecting, and user time was 0, system time was almost 0 because the script was mostly idling. So if you just paid for very big machine and you have a big amount of data to process, and you have a function that can, for example, take a file that needs to be processed, and you have dozens of files, you just run a function in a Go routine that will parse that file, and all the resources will be used. Very simple, very easy, and nothing to worry about. There are a lot of constructs in Go that allow you to have safe concurrency, and it's very, very efficient. It's something like a green treat, and there is almost no cost to run it. Very low memory overhead, very low CPU overhead. So you just start any amount of Go routines that you like, 1 million of them, no problem. The implementations that run 1 million WebSockets, each in its own Go routine on single server, are not uncommon. It's very, very common approach in Go. And it's even not complicated. It will be like 100 lines of code. So what we have learned today, why Bash is not always okay. You can use it for small things, but if it started to grow, then consider something different. It can be Python, it can be Java. I've just presented Go because I think that it's easiest to use in the scripting approach. What is Go actually, if you didn't heard about it? How to run Go programs as a script. So you just change mode plus X and go. And how does simple Go programs look like? So some scripts example. And yeah, that is all I would like to talk to you about today. So thanks for the attention. And I don't know if we have time for one question. Even more. Okay. So now I'm open for questions. If someone doesn't want to ask it now, then I'm available around. So yeah, we have a question. Okay. So
Okay, I will come to you with microphone.
yeah.
Okay. Have you ever tried to use the Holy C for the same result? It's the language designed by this, I don't know, programmer, like a bit known on the internet. He's like this schizophrenic guy who created the Temple OS operating system, and he also created this funny language, which he called Holy C, and he used it for scripting all across his system. You can look it up. It's a funny thing, but
Okay.
it provides similar benefits that Go provides.
Okay, I will need to look it up because I didn't use it. Mostly due to the fact that I would like to integrate with Docker or Kubernetes, and the client library is in Go. So if there is a nice client library, yeah, I can try it.
I don't think that there's a client library, but just look it up just for fun.
Yeah, I will try. Yes, please.
We can have something similar to bin fmt on the Mac or Windows, or this is only Linux?
On the Mac, there was something, and I think that there is some application that you need to download something. In general, no. No.
Okay, I see another question.
There was one also here.
You asked about Mac. I'm not sure, but I use FreeBSD myself, and it works on FreeBSD as well.
So there is a big chance that it will work on Mac.
If Apple ported it, then it should work.
Yeah. So question is if Apple ported that BSD feature into the Mac kernel. And there was one question here, yes? Okay.
Okay, I come.
I have the question about libraries. Can I find some well-documented, what can I use, for instance, to regex, text parsing, easy-to-use libraries?
In Go?
Yes.
There is a golang.org page, and the regex is the default package, so it's built into the Go. What else you'd like? JSON is also built in. The encodings, a very, very large amount of different encodings, like base64, all that stuff. It's all on the golang.org/pkg. So packages. And if you want to try Go, you just go to the golang.org webpage, and there is like a browser version of it, so you can learn it in the browser. You don't need to install anything. You just can take the Go tour inside of the browser and see if the language is a fit for you, or you don't like it without any installation. So half hour of your life, and you will know if you like it or not.
Okay, thank you.
Thank you very much.
So now the switch time.